So Bur Oak Blight, it overwinters on those petioles that I mentioned and the disease leaves that stay up there. This sounds like a pretty clear way to diagnose it, but the tricky part comes in that this can look a lot like two-line chestnut borer as well. And the warning is that both might be going on in the same tree at the same time. So that's why diagnostics come into play. And I'm always counseling people to do a full diagnostic inspection of the tree because of a Bur Oak Blight can resemble and mask other things going on. And the diagnostic, this goes as to whether you're getting ready to do plant health care, you know, a diagnostic situation for a tree, or if you're going to climb a tree, a pre-climb inspection. It always starts from the base upwards. Check that you have an intact root flare, rule out any kind of damage or infections to that root area. Because if you have something going on like an armillaria root rot situation or mower blight, that's kind of a game ender, or that can render all the rest of your diagnostics a moot point. I've learned this the hard way before too, because I can remember about 10 years ago a large bur oak in a client's backyard, and I just at the first glance saw some dieback in the crown, and it sort of looked like maybe two-line chestnut borer, maybe early arrival of oak wilt in this bur oak. And I'm immediately jumping to this conclusion of how I'm going to be the savior of this tree and the heroic arborist. And I started cutting samples and checking and verified the two-line chestnut borer, the oak wilt, and then I'm putting the diameter tape around this tree to figure out the dosage of the product it'll take to bring this tree back around. And as I glance down, when I'm putting on the diameter tape, I notice the mower blight has girdled about 80% of the circumference of this tree, and probably we're not going to get a very good distribution of some of these products up in there to try to save this tree at that point. And by skipping ahead right to the crown and jumping to conclusions of how I'm going to save this thing, I skipped what was a fundamental, like literally at the base of the whole problem, what was going on. So that educated me to always start a diagnostic from the base upwards and rule out root flare problems first before you start looking at everything else. And if you're not familiar with this armillaria fungus, all arborists should be very aware of it. It's one of those few tree diseases that is fairly indiscriminate in the host it will attack, where most tree diseases we deal with are just specific to one kind of thing. Like oak wilt is not going to attack elms, and Dutch elm disease won't do anything to maples, but armillaria fungus will attack any place where there's an injured root flare in almost every woody plant species. So if you don't know armillaria, get to know that. They call it shoestring fungus because in the advanced stages it'll leave behind these black shoestringy things under the bark. And at that point the tree is pretty visibly dead anyway, but there's no treatment for this fungus. It's just kind of either a slow or a fast death at that point. But it's just kind of a long way around of saying start your diagnostics from the ground up and do the diligence that way. So top of the list in any oak situation, you want to be able to rule out if there's oak wilt going on in your oaks. And I know that oak wilt doesn't have a uniform distribution throughout the range of oaks, and it seems like in our upper Midwest area we really get picked on with oak wilt, but they don't apparently have it up in Canada or even northern Minnesota. But in our Twin Cities metro area, it's very common. It's just part of the everyday life of an arborist during the growing season to deal with oak wilt situations. So you need to know how to diagnose that in the field and how to have the connection with your local plant disease clinic at your extension agency to send in samples. But typically I will try to verify on site if I can if there's oak wilt, and do that by collecting a sample that's about 1.5 to 2-inch diameter right at the transition line between where there's symptomatic and non-symptomatic tissue. And as you can see from this picture I've got here, there's almost a barrier zone that's been formed just above the tip of that knife that forms kind of like that cutoff line between where the dead part of the branch was and the live part. And back right by the tip of the knife, you see that staining reaction in the sapwood vessels. And when there's oak wilt, that's just going to stay consistently in that line with the sapwood vessels back behind there, as the oak wilt is moving through the tylosis formation, triggers all this wood discoloration. And you can send this in to a disease clinic to get it cultured and verify it, but typically in my cases, if I see this kind of streaking that stays right in line with that level of sapwood, I'll just do the oak wilt set of protocols. And I don't want to go through a whole thing on oak wilt right now. You know, that's a whole webinar unto itself, but at least pointing towards a diagnostic feature that, you know, you should make sure that you're doing the diligence to identify if you have oak wilt or not at the same time in a Bur Oak Blight tree that you're taking under consideration. Then two-line chestnut borer is also very common with our Bur Oaks. It can also cause staining in samples, so that muddies the picture a bit. You know, almost anything that causes a wound in the bark or the wood, you can get reaction zones starting, and it can make a confusing array of appearances in the tree. But if this tunneling or that staining looks like it's got the transverse meandering tunnel through the twig there, that's the activity of an insect that's boring through the phloem tissue. So that can end up creating a staining, but you know, contrast this to the staining that just stays right in line with those sapwood vessels. The chestnut borer has a different look to it. So doesn't mean that you rule out oak wilt if you've got chestnut borer. It might be going on in the same tree at the same time. But if you do find this D-shaped exit hole just above and a little to the right of that tip of that pen there, that's about the size of a capital D on a typing paper in a 12-point font, roughly speaking. And it's the same kind of exit hole that you would find with a bronze birch borer or emerald ash borer, because two-line chestnut borer is in the same genus. So that's the definitive sign that tells you that you've got one of these borers in your tree. So if you see that, then you know you've got the chestnut borer in your Bur Oak. Now, yet another thing that has been piling on with oaks in the last handful of years is Botryosphaeria canker. Botryosphaeria is kind of a large genus of canker-causing fungi that have a wide host range, but the Botryosphaeria quercuum, the one that attacks oak trees, can make this sunken canker that has the callus around its edges, like you'll see in this picture here. And the foliage, the leaves at the distal end of that branch, or the end farthest away from the trunk, might be stunted or thin or dead and adhering onto that branch that's on the tree, and these are somewhat randomly distributed throughout the tree. So the tree is acting kind of strange, kind of like oak wilt, but not really, because it's not dropping a whole bunch of leaves all at once, but there's just little pockets of it scattered through the crown, and then your sample will show, if you're lucky, you'll find this canker with that sunken edge, but plenty of times you might not even find that canker. And peeling away the wood, this is another case where you can find staining in the sapwood. It might give you a false alarm about oak wilt. So, you know, it's good to send in samples. And if you're sending in samples too, of course, I always throw in the caveat, like, don't just throw a sample in the back of the truck and it sits there during a hot afternoon. That will render that sample into a false negative. Maybe there's oak wilt or something going on in it. But put it in a Ziploc bag so it doesn't dry out. You cut samples about 2-inch diameter, 6 inches long, with foliage still on there if possible. And you put it in your lunch cooler and get it to your disease clinic right away so that it stays viable. You know, it's a living kind of thing. And if it dries out or gets too hot, you will probably end up not getting a good result out of it, or maybe get a false negative. So another interesting twist that's come up in this whole examination of blights on oak trees at our University of Minnesota Plant Disease Clinic, they've given us back samples we submitted from red oaks confirming a Tabackia species on red oak trees, where red oaks in our northern suburbs, where we've got kind of a sandy outwash soil area and a lot of red oaks predominate up there, we've seen red oaks behaving in ways like as if it was Bur Oak Blight. So the Forest Service office and the Plant Disease Clinic wanted me to really emphasize that red oak is not a confirmed host of Bur Oak Blight, that the fungus Tabackia iowensis has not been isolated from red oak, but right now they're just calling it two other distinct species of Tabackia. They're calling it C and D that can cause red oak symptoms, and especially the leaf spotting. So, you know, plant pathologists want to make sure that they're very precise about everything and that we're not kind of creating confusion about that all sorts of different kinds of oaks are getting Bur Oak Blight. So maybe we'll eventually call it red oak blight, but right now it's just Tabackia C and D. Now, in the topic of diagnostics, there's our page, treecarescience.com, has loads of diagnostic information and pictures and protocols if you go there. So good resource for all kinds of information to mine into. Now we get to disease triangle. It's a rare presentation I ever give that doesn't somehow make a reference to this disease triangle. And as an integrated pest management concept, it seems so elementary, so basic, like big deal, what can that tell you? But really once I've latched onto this, it's given me kind of a lens to view everything I do as a practitioner, more or less. I kind of run it through this perspective so that it gives me kind of a reality check about what's going on, you know. And the idea is basically like you have to have these three things all coexisting for a disease or an insect infestation to occur. That just having a pathogen drifting spores around in the environment is not a disease until there's a host that has a susceptible level of tissue out there for it to land on. And then the environmental conditions have to be in favor of allowing that spore to germinate on that tissue at the right time and place. So until you have all that, there's no disease yet. So why does that seem so earth-shattering? Well, it gives you a perspective into some things that we can change within that go beyond just our reflexive reaction is to pull out a spray hose, or I think of it as the got a problem, take a pill approach in our society. Like I've got a staff here at Rainbow of 18 consulting arborists, and you know, there's a treatment guide that I've got that's a 15-page sheet of protocols for how to kill things, you know, and that's what we want to do. You have a cough, you take some codeine. Well, what if you're smoking a pack of Marlboros a day? You know, how about if you change that along with your other practices? That's kind of where it points to, can we change or modify that environment to have it less favorable for the disease? Or can we change or modify the host to increase its vigor or reduce the stresses on it, so that it's not just all about how do you control a pathogen, that you can increase your effectiveness of the treatments you do by looking at the other areas in the disease triangle. And there's a strength involved in this as well, that it takes the pressure off from you from delivering miraculous results where your client is saying, well, I'm paying you this money to treat this and I expect it to just kind of miraculously turn around. Well, if that client is doing wrong cultural practices or over irrigating or doing things that are kind of stacking the deck against you, then you're not going to spray your way out of that problem. But if you kind of enroll them, bring them on board with their part in what they can do to manage the situation, a lot of clients are very happy to kind of be your partner instead of put you on the spot, you know, that they're involved in it, and everyone's going to have better results and a more realistic alignment about what you're up to. So this is why I'm so enamored of this whole idea of disease triangle. It provides a framework and shows you how things work, but it also points towards situations like Bur Oak Blight. Like there are some things we can change in the scenario here, but there's some changes we can only respond to. I'll explain more about that here as we get into the environmental corner of Bur Oak Blight. If you see on this map, The gray zone marked out here is the range in our continent where Bur Oak Blight occurs, and down towards the bottom in the more southern states into Texas is cut off there. But Bur Oak has a very extensive range, goes way up into Manitoba and even southern Ontario quite a bit. But the red areas are where Bur Oak Blight has been confirmed. And as I mentioned early on, Iowa, it's pretty much everywhere in Iowa, hence the name Tabackia iowensis. Minnesota, we've got quite a lot of it too. And you can see how in Minnesota it just follows exactly along our prairie forest border. Our northeast chunk of the state is kind of just more of a conifer forest area. But the rest of the state, where you kind of follow that diagonal slice through Minnesota, that's where this prairie forest border savanna has existed since the last glaciers left behind and vegetation started to cover the place. Other states that border us in Minnesota and Iowa have had Bur Oak Blight confirmed as well. You know, parts of Illinois, the edge of Wisconsin, Missouri, but the bulk of this is the Iowa-Minnesota thing. And it seems to match up with our changing environment. So we're still looking in that environmental corner of our disease triangle. The projections for what the climate is supposed to be doing based on all the modeling is increased winter and spring precipitation with drier summers. And this is borne out by our local experience here, that it seems like I can't remember a dry spring that's happened in the last 10 or 15 years. It just seems like once May comes, it's raining continuously, and then maybe it shuts off and you get some drought. But if you look at these maps here, the blue means increased precipitation, and then darker colors means drought or decreased precipitation during these different seasons. So that is borne out by our experience, and that shift in the precipitation pattern is what's putting Minnesota and Iowa and the neighboring areas at higher risk for Bur Oak Blight. That Tom Harrington, who's done a lot of work on this from Iowa State, points out that these prolonged spring rains are the most important factor in increasing the rates of Bur Oak Blight. So if we look at the disease cycle of how Bur Oak Blight works, those petioles that are adhering on the tree that are infected, I pointed out earlier on, spores will get activated in the spring, and those happen to be right near where new foliage is starting to open up. So you've just kind of got the perfect proximity for an infection to occur during a prolonged spring rain and wind and splashes happening. Those new leaves get infected. So there you see that wedge-shaped necrosis, and in the summer that leaf infection moves down into the petioles and even into the twig tissue. And then by fall and winter, it's starting all over again. Those infected petioles are adhering onto the tree, and the cycle just keeps going until that can build up in the tree. So, you know, prolonged spring wetness is the perfect set of conditions that get this stuff started. Now, if we shift from the environmental change that we see up into looking at the host, another piece that I've learned from Tom Harrington is that the legacy, the relic Bur Oaks that we have established throughout our prairie forest border area, the classic kind of spooky looking silhouette Bur Oak tree, those established over long stretches of time when spring drought was more common. And Tom's even pointed out specific varieties of Bur Oak that are more susceptible within the whole gene pool. There's one he calls Oleviformis, or the small acorn Bur Oak, the Quercus macrocarpa oleviformis. So when you had centuries of oaks building up their genetic pool, when you just had more common spring droughts, there was not the conditions there to build up Bur Oak Blight. And it's apparently a disease that's been around a long time, but way back before settlement, when it would just show up in pockets here and there throughout large areas of savanna, it didn't really occur as a major problem or threat. Then when you fragment that original cover type down to a small percentage of what it was and increase the spring rains, then the whole picture changes in that disease triangle, that it emerges as a bigger problem that we have to try to figure out what to do with it. So while there's a variety of bur oak, the oliviformis, that tends to have a greater susceptibility, there's also varieties that Tom has identified as having more resistance, apparently. The macrocarpa variety, macrocarpa, or the large acorn one. So the long-term strategy on the host end of that triangle is to start planting more bur oaks with larger acorns. And this sounds great, but in my case, you know, I'm going out, I'm diagnosing trees, and it's not the acorn year. So I'm not really noticing, I'm not correlating which size of an acorn does this tree have, you know, and when it is an acorn year, I'm not necessarily out there looking for Bur Oak Blight too. So it's something that I have to start tuning into, or that we all do. You know, we may be up against a genetic and environmental problem here, and that this is one of our longer term planks out of the situation while we're trying to figure out how to treat the pathogen. Now there are nurseries, at least one practitioner that I know in Northfield, Minnesota, Life Connect. He is propagating open pollinated oaks. He's got a number of named varieties of oaks. I don't remember the names of them, but he allows them just to open pollinate, cross pollinate each other, and then he staves those acorns and grows the seedlings out of them just to build the genetic diversity within the oak genus. So it's one thing to promote diversity of species in your plantings, and that's a good thing, but then it's even a step further we can go is to build the genetic diversity within the species that we're working with by allowing for more cross-pollination, open pollinated situations. So it's not for everybody. You won't get the uniformity for plantings, but you know, uniformity can get us in trouble in a lot of ways too. But at least there's this one nursery that I know where he's working to boost host genetics. So if we're looking, going back to that environmental corner of the disease triangle, what kind of changes, if you are able to make changes in the environment around a stand of bur oaks or a bur oak, maybe it's a possibility to clear away vegetation and increase airflow or light. If you've got populations of buckthorn or other invasive species or woody stuff underneath the tree that you don't want or need to have there. On a larger stand level, this might be something within your reach. You know, maybe you don't have the budget or the means to treat a whole bunch of trees, but there is a way to go in there and start cleaning out something that's clogging up the airflow underneath. Environmental changes too, when you can get in there with an air spade and loosen up compacted soils, introduce organic matter, that's always a good thing for any kind of tree, but especially oaks. You know, the wider the area you can do, the better. In our services division here, we generally offer a 3-foot or a 5 or a 7-foot diameter ring from around the base of the tree. But if you have a client that's willing to go all the way out to the drip line, and I haven't seen it happen very often other than Wellesley College out in Boston, where the campus arborist had done the entire square footage under a beech tree with about an 80-foot crown spread. But they're willing to go to whatever length out at Wellesley to take care of their trees. But you do this and you're kind of turning a soil into almost like a chocolate cake consistency. It's just roots can't help but grow in there. So it's just an environmental modification that's good for Bur Oak Blight situations or anything else. Now, looking at the host again, what's within our reach to modify the host to build disease resistance? There's tree growth regulators, especially, well, Cambostat. A lot of you might already know about this slide that's used quite a bit. It's basically showing how if you reduce the impetus for a tree to grow its crown and put the energy into growing its crown, that can release that energy into other side pathways that are beneficial for the tree. One of those being increased chlorophyll production in the leaves, or you'll get a thicker, waxier cuticle over that leaf surface that tends to resist infection from fungal spores. There's also a lot of new fine root hair development that occurs after use of Cambostat. And there's been a study, Gary Watson did a study about apple scab resistance. So this hasn't directly related with Bur Oak Blight, but just from my own experience, Bur Oaks seem to do very well with Cambistat. It's not a species that I would fear over-regulating. Not like I'm saying overdose them, but Bur Oaks do seem to respond well and get a nice dark shiny green leaf and seem more resistant to a lot of things, whether it's oak anthracnose or Bur Oak Blight, etc. So Cambistat growth regulator is a good way to increase the resistance of the host. And a lot of our plant healthcare treatments are things I think of as like external applications trying to block a pathogen, whereas a tree growth regulator is an internal impetus that you're changing in the tree to actually modify the host itself instead of just going after a pathogen. So a thing really necessary to point out here, when I did the research before going to Iowa for that audience, what to clear up when we're talking about Cambistat. What was apparently happening in Iowa was people were trying to use it as a tank mix, Cambistat with Alamo fungicide macro infusion, which then they'd complain it would gunk up the equipment, and it's no big surprise because Cambistat's not labeled to be a compatible tank mix with macro infusion equipment or other products. The way you apply Cambistat is either as a basal drench where you dig a little moat around the base of the tree, or as a soil injected product through proper kind of equipment, such as the HTI soil injector. Very simple to use tool, and it'll give you a 250 milliliter shot, dose per shot, and it keeps track of how many shots you've done. So it'll save you a lot of money and get your treatments done correctly. So really good tool to have. Now controlling the pathogen down in that corner. If Bur Oak Blight starts as a leaf infection, well, why don't we just spray for it? Well, because a lot of our patients, or trees that we're trying to deal with in this condition, are the really big, tall trees, and they might not even have canopy down low enough for us to spray. Like this picture shows, it's probably from the earlier mid-1990s, way back when I started and I was a plant healthcare technician at Rainbow. I would be this guy shooting Dursban 60 or 70 feet up in the air into oak trees to try to control two-line chestnut borer. And now, because of systemic insecticides, we don't need to do that anymore. But our integrated pest management practice has led us away from even using gear that will shoot up that high, because it's impossible to not have massive overdrift. Right now, our spray equipment, maximum height we can throw a spray is 30 to 35 feet, which is very sufficient for us to treat foliar fungi like apple scab, smaller sized trees, or lower parts of conifer trees with needle cast disease. But we basically don't really need to shoot things up into crowns really high anymore. And IPM practice has pointed us away from doing that. So that will kind of take foliar sprays off the table if you're trying to do anything about Bur Oak Blight. I don't know of any arborists really relying on foliar applications for Bur Oak Blight. I mean, you could certainly treat, if you have smaller Bur Oaks with canopy down low within reach of your spray gear, you could do that. And it's certainly not going to hurt if you get that foliage coated with a proper fungicide at the right time. But in most cases, what we're dealing with is trees that are way outside the reach of what we currently are using. This macro infusion with Alamo has been our current protocol for the past 5 or 6 years. We've been doing a rate of either 8 to 10 mils per diameter inch and applying it just before full leaf expansion. There's this kind of arbitrarily chosen 13/16 leaf expansion, and the full disclosure on the story of that is that for a while we were saying we would send the treatments out at half leaf expansion, and then my arborist would complain it was too early, and then we'd try to send it out at 2/3 of leaf expansion, and this was based on studies that Tom Harrington did at Iowa State. And I'd keep getting complaints about it's too early, too late, until I just kind of concocted this 13/16 leaf expansion out of thin air and gave it kind of an authoritative sound to it. So half the group thought it had some real basis, and the other half knew I was just totally blowing smoke. But, you know, the thing is, if look at any given tree at any given time, can you tell me what a half versus a 2/3 of a leaf looks like on one branch or throughout the crown of the tree? And then consider your metro area, south suburbs all the way to the north suburbs. It's kind of a gray area. You know, the main thing was we were just trying to get it injected in the tree before the leaves had fully hardened off. We wanted to get product out into the tree as these spores would be arriving there, germinating on there, to try to get a preventive establishment so that spore couldn't germinate. And then it would be repeated every 2 to 3 years as needed. So for 2017, we're changing the protocol up a little bit, going for an earlier start. We're going to go at bud break, which should be within the next few weeks here in our locality. And we're going up to a little higher dose for the larger trees, like 15, maybe even 20 mils an inch. It's a pretty rich dose, but trees 25-inch DBH and larger, we're actually wanting to get a little bit of scorch or phytotoxicity on these trees. And by the phytotoxicity, I mean this reaction where you'll get the browning or gray kind of ghosted out look on the leaves, and maybe it just stays green along the veins. This happens sometimes to oaks that get an Alamo injection, ones that we treat for oak wilt. We haven't seen it kill a tree before, but the ones that improved the most regarding the Bur Oak Blight are the ones that got a high enough dose to get a phytotoxic response. And this has been consistent with what I've heard from down in Iowa too. There was an Iowa DNR guy who said that his rate of improvement on Bur Oak treatments was pretty high, like 80%, but he's trying to dose it to the point where you get a little bit of the scorch on the tree. And it may just need to have the, you know, blow the leaves off so that those petioles are not adhering on there to provide an inoculum for next season's infection. So if you're aiming for this phytotoxic reaction, you really have to do your homework and prepare your customers for it ahead of time. Expectation management is key. Let them know that this might happen, because if you inject it and then it happens and you try to explain it later, they think you're just completely making up some story and trying to paper over some mistake that you made or that you overdosed the tree. But if you tell them ahead of time, this is kind of what happens in many cases, and then it happens, it's going to be a lot easier situation to respond to at that point. So as I was saying, the goal with the Alamo injection is to reduce that late season inoculum. If we are able to blow these leaves off or prevent them from having these spores build up and germinate in there, we'll hope to reduce the rate of reinfection in the tree. So it's going to take a few seasons to look better as those petioles that were adhering on there from before break down and fall away. You know, the previous ones that are adhered on there, they might stick on there for a while until, you know, nature takes its course and they fall off. So it doesn't always improve right away. Now, just wanted to make sure that I fit this in here too. I had mentioned two-line chestnut borer, very common on bur oaks that are under stressed conditions. So if you've got multiple seasons of Bur Oak Blight building up along with other things, two-line chestnut borer can start hopping in. If you are doing an Alamo injection, Zytect infusible is very compatible as a tank mix. So this might have been where people got mixed up with Cambistat, putting it in with their Alamo macro infusion. Don't do that with Cambistat, but by all means, Zytect infusible can go in at the same time, and you get kind of that silver bullet against the two-line chestnut borer at the same time. So the results of our treatments last August and September, I went out and visited 54 sites that we treated in 2015 and 2016 against Bur Oak Blight, and these were trees treated at the 8 to 10 mil rate per diameter inch. So what was our standard at the time, regardless of tree size? Oftentimes these were in combination with cambostat treatments, the soil application. And what I saw is about 50% of the trees improved and 50% was like we didn't do anything. The best results were the trees that were out in full sun exposure, which seems to correlate to, well, less fungal attack where you get more sunlight, ventilation, etc. The worst trees were the ones that had buildings right around them where they didn't get a lot of access to sun. So maybe currently the best therapy for Bur Oak Blight is sun exposure, but it's not like you're just going to tear down some houses to let the sun get on your Bur Oaks to get them to improve from the Bur Oak Blight. So we have to deal with the layout of our landscapes the way they are. We are looking for a way to get an increased rate of effectiveness because, you know, we're talking about giving predictable results. Well, you can flip a coin and get predictable results, but that's not a rate of effectiveness that, you know, if you're just getting 50% improvement, we want to get an increased rate of effectiveness. And that's why for the 2017 season, we're partnering with City of Minnetonka. It's one of our western edge suburbs of Minneapolis here. They were kind enough to enthusiastically offer up 88 of their Bur Oak trees in their parklands. And Minnetonka has a lot of beautiful forested parkland around. So they had already mapped out 88 trees they had identified with Bur Oak Blight in them. So myself and a couple other Rainbow Tree Care Scientific Advancement staff, we went out and visited these 88 trees, mapped them out with a GPS, and did a condition rating, upper and lower half of the trees. And the trees that were too far gone, we left out, and the trees that were only lightly infected, we left out. And then trees that were too remote, too hard to get to with gear for injections and treatments, we left those out too. So that winnowed out from 88 trees down to 30 that we're going to have in this trial. And within the next couple of weeks, as the trees start to get to bud break, then we'll do an array of treatments like with the standard protocol, and then, you know, the 8 to 10 mils per diameter inch. That's the old way. We'll move another set up to 15 mils per diameter inch. We're going to try a set with Arbitect that we'd normally use with Dutch elm prevention or sycamore anthracnose. And there may be another novel product that's going to go into the study as well if we get the approval from the City of Minnetonka to go that route. So we're looking for some new ways to go about doing this so that we can increase our rate of effectiveness. But mainly on our services side, we're going ahead with earlier treatment and higher dose on the larger trees is the main takeaway for right now on that. So just to review and wrap it all up here, identification of Bur Oak Blight. If you see those infected veins on the underside of a leaf, wedge-shaped area, the necrosis, adhering infected petioles stuck up in the tree, that's a good chance you got Bur Oak Blight. But don't forget to do a full inspection of the tree starting from the ground up, and be aware of an array of other conditions that you might have to be dealing with too, or at least try to rule out, like your oak wilt, chestnut borer, Botryosphaeria canker, all those types of things. And just look at it, whether it's Bur Oak Blight, or once you start looking at things through this disease triangle perspective, it'll kind of color everything you do as an arborist. Like, what's going on with the host? And is there an environmental condition here that's gone beyond its normal range or levels of precipitation? Or what can we do to the environment to make it less favorable to that pathogen? Because right now, at least in Bur Oak Blight, we don't really have something that's reliably killing this pathogen in the right way. So the disease triangle gives you a full perspective on what's going on, and outside of just got a problem, take a pill. Some of these treatments are working and some of them are not, but don't tank mix cambostat in your Alamo macro infusion. And basically we're working towards something better, and we'll see what this next season brings. So thanks for your time and attention. I appreciate people tuning in.
All right. Well, thanks, Kent. Before we get to the questions, I just want to put out another reminder. to get your ISA CU for attending this webinar, please make sure to enter your ISA certification number into the questions and chat box, and we'll make sure that you get your CU for attending. All right, so let's go ahead and take a look to see what questions we've got here. And again, if you've got anything that comes to mind right now, please go ahead and type that into the questions and chat box. All right, so the first question we've got here, are white oak susceptible to Bur Oak Blight?
I don't know that white oak are. I have never seen that or heard of that going on, but it's very particular to bur oaks and especially to that oleviformis variety of bur oak. And it can get confusing too, like there's plenty of white oaks and bur oaks that tend to cross-pollinate, make intermediate forms, but I have not seen white oak with Bur Oak Blight. I have seen it with Botryosphaeria canker quite a bit though. So the white oaks in the past handful of years get these odd twig symptoms like they are getting the canker disease, but not Bur Oak Blight.
All right. Any other questions? Just here we go. I've got a question. Clean saw if you take oak wilt sample?
Yeah, it's not a bad idea. I keep isopropyl alcohol in my kit just to, douse my saw blade down so I'm not going to inadvertently transfer some kind of pathogen to the next tree. It's just kind of good practice. So, yeah, good idea. Lysol or rubbing alcohol is a good thing to have. And what was the Rainbow Tree Care website you showed around 3 or 4 slides in? What if that was the treecarescience.com diagnostics page? That must have been, yeah, there's Tree Care Science diagnostics page. That may be the one that you were talking about there. Is bot canker very bad? From Craig Wilson. It can be. I've seen it very unevenly distributed in trees, even in a swamp white oak where a whole branch was killed, and that was a tree treated with cambostat, and it seemed like that kept it from moving throughout the rest of the tree. It's not something that rapidly moves through a tree like oak wilt, but it seems to just selectively kill a branch here and there. And in some cases, it moves right into the trunk and makes a canker. But I haven't seen it like wipe out a tree stone dead. Oh, wow. Oh, of course, that's Steve Thompson commenting best he's heard on Bob. But of course, Steve is going to give us big praises.
All right, so we'll stay on the line for just a couple more seconds here to see if there are any last questions.
What kind of time frame between Bob injection and cambostat? I was saying the injection, we're looking to start those when bud break happens. That's a departure of what we had before, where we wait for some leaf tissue to build up on there, but before the full leaf expansion. Now we're going at bud break on that just to see if we can hit it earlier, and it will be less of an investment for the tree to have to rebuild new leaves, but also maybe hit it harder that way. The cambostat, you can apply that really anytime the ground will accept it. So, that's basically in our area April through November. So that's not very tightly controlled timing on when you apply cambostat. We always appreciate sharing his real-world experiences. Great, thank you. Have you conducted starch tests to determine susceptibility? Haven't done starch tests. That's a good idea, though. I like that idea. Yeah. Thanks for the tip, Mark Weber. Oh, the condition rating was 1 through 5, upper half and lower half. Was just trying to find consistency with how Tom Harrington had done his studies. So it would be given 1 through 5, upper, lower, so that we'd have two rankings for each tree. In some cases, the lower part of the tree looks really bad if it's shaded, and the upper part looks good if it's out in full sun. Yes, 15 mils for 25 inch and over. And that, of course, is, I'll stress too, just what we're out there, we're going to try. So that is just experimental. So, you know, proceed at your own risk. That's kind of what we're going for with that. Like, that's not etched in stone protocol. That's just us trying something new to see if we can get better results. So that's, you know, buyer beware. So I don't want to mislead anybody about that. This is purely experimental territory here. Yeah, are you now recommending trees? Yes, if it's the smaller trees, like 25-inch DBH below that, just stick with your 10 mil rate for now.
All right, well, we'll go ahead and wrap things up here. Thanks again, Kent. I do want to put in another plug for salutingbranches.org. Again, if you want more information, you can go to that website to get the information. Also, at the end of this webinar here, we have a post survey. So if you could fill that out, it's anonymous and it's totally voluntary. If you could fill that out, that would be fantastic. We're always looking at ways we can improve what we do and what we offer here at Rainbow. So thanks again for all of you for joining us today, and have a great day.